After an easy 1 hour flight, I returned to the Compton airport for a landing in the Audis Titan Mustang. That's when the gear collapsed on landing. I was able to catch it and power up and go around. Before I could get the gear to relock, the engine quit. And I had to dead stick the airplane with the broken gear back into the Compton airport. I'm Elliot Seguin. Let's talk about how this happened. Alright, welcome to the Audis Titan program debrief video. I apologize, this is a really long one. We're trying to fit a whole program into one video. So yes, the program ended in an incident at the Compton airport, but in this video we're going to go all the way from the initial connection with Jim Audi, the owner of the airplane, all the way through the 3 flights in the airplane, and then finally the incident flight. I recognize it's a long journey. I recognize this video is really long. If you have to use the timestamps, please do, but I think that coming along for the whole journey will help inform how we ended up where we did end up. Thank you for coming along. Before we get too carried away, I want to thank some of our sponsors. Method 7 does a fantastic job of not only creating great aviation eyewear, but also supporting important culture within our little niche inside of aviation. A big thank you to them for their continued support. I'd also like to thank Butler Parachute. Butler's line of high-speed opening emergency parachutes gives me the confidence I need to do the work that needs doing, and I appreciate their support. And lastly, I want to thank our Patreon supporters. Thank you to those folks that are doing that. It means a lot. The Titan T-51 Mustang is a 3/4 scale Mustang replica designed by John Williams of the Titan Aircraft Company in South Austinburg, Ohio. You may recognize the name Titan Aircraft from their line of Tornado ultralight aircraft. The ultralight roots are strong in this airplane. Of the Mustang replicas that I've flown 3, the Thunder, the Stuart, and the Titan. The Titan is by far the most practical entry into this class of aircraft. The aircraft is made up of steel tube fuselage covered in aluminum and an aluminum wing. It has fabric covered control surfaces. According to the FAA registry, there's approximately 60 Titan Mustangs, the bulk of which are Rotax powered. The Suzuki V6 was the initial power plant for the airplane. Again, I'm not an expert. If you want to know more about the Titan, I would go talk to Titan. However, from what I've been able to gather, the Suzuki V6 is sort of the engine that started the kit off. A lot of them ended up flying with a Rotax, and then the current engine of choice is the LS Chevy V8. This very much matches the history of this aircraft, which started out with a Rotax, flying approximately 100 hours with that Rotax engine installed. And then the 350 horsepower LS3 was installed for the last 40 hours or so of the airplane's existence. The LS installation is automotive in its engine controls. Both the fuel injection and the single plug ignition are both automotive and non-redundant. This of course means that the electrical system is critical for the engine to keep running, which is a concern. But again, in the light of 40 trouble-free hours from an engine management standpoint, I believed the risk was reasonable. The LS swap was done at the Titan Aircraft Factory by John Williams in Ohio. We were first approached about the airplane while it was still in Ohio. The owner, Jim, purchased the airplane and was looking for a way to move the airplane from Ohio back to California. Jim is not a pilot. This is the first airplane he's owned. This was sort of an outside-of-the-box purchase for him, and he was looking for some help. We were pretty busy at the time, and there were plenty of people that wanted to help with the project, so he was able to find some other folks to help him get the airplane moved from Ohio out to the Compton Airport in Los Angeles, where it was flown a few times before we were brought on board. Some of those flights are documented on Jim's YouTube channel. I suggest you go check it out. When we were brought onto the program, they were dealing with a persistent gearbox issue. The airplane had flown from Ohio out to California with apparently no trouble. Then the checkout flight where Jim's pilot was getting checked out in the airplane, the gearbox had a problem. They then replaced the gearbox. The new gearbox came in. the company pilot flew the airplane, and then the gearbox ran away again. So here's some footage of Ethan's last flight in the airplane. It's worth noting that I didn't have this footage when I flew the airplane, so the stuff that's pretty apparent in this footage was not available. That information was not available to me when I flew the airplane. It's also worth noting that I was not able to get a hold of Ethan until after my last flight in the airplane. There were some communication issues. I think both of us were putting our best efforts in. It just we weren't able to connect, which was a real disadvantage. So you can see the power come up, looking at the propeller, as well as listening to the engine sound, so you can hear the RPM vary. You'll see him stand the tail up, so there comes the tail now. Yep, tail comes up. Pretty proud height there, looks good, and then he settles it back down and goes in and tries to fly there. See how the tail never really comes back up, but the plane doesn't really start climbing. You can see he's very busy directionally in pitch and then a little bit in roll. And I think all this is indicative of a busy pilot, busy with an engine doing things that he can't predict, which is what he told me later on the phone. Again, talking about the airplane here, not talking about Ethan's flying. I think he did a great job. It's worth noting that Ethan passed in a motorcycle accident after he and I talked after Flight 4. So I was able to talk to him. We were able to debrief both his flight and my flight. Seemed like a really solid dude, and then he was lost. So I'd like to dedicate the video, if I could, to Ethan. And that's when Wasabi was approached for the program. From our perspective, this was for the most part a proven airplane. With roughly 140 hours on the airplane, 40 with this engine installation, it seemed like we had made it through the sort of the bathtub phase of risk for the program. So that bathtub being described as most of the risk is likely in the infancy, sort of infancy failure sort of situation, and then the risk drops into the bathtub phase through the life of the product, and then sort of at the end you have a likelihood of failure at the end. So that bathtub concept, the idea was by getting through the first 140 hours on the airframe, 40 hours on the engine, we'd gotten through that super high risk phase, and for the most part you weren't going to have basic mechanical failures, that kind of stuff. However, obviously the gearbox was a major highlight, and so I really kind of became laser focused on the gearbox. Despite all this, we started the program where we start all of our programs. So I started by just an aircraft inspection, which, like we've talked about in other videos, looks a lot like a condition inspection or an annual inspection. So pull all the access doors off and go from the airplane system by system, tip to tail, wingtip to wingtip, and try to get a feel for what's going on. Again, like we've talked about in other videos, a lot of what you're doing here is not only looking at the physical hardware, but trying to understand what the relationship with the owner is going to be like. This was a particularly interesting program in that regard, because the owner, who was now taking over the maintenance role, didn't have any aviation experience really. There was a lot of just trying to figure out what it is he wanted to get out of the program, and then therefore how we could add value, independent of course from the how much risk are we taking on, and what's the safest way to move forward, both for pilot physical risk as well as risk to the airplane and risk to the program. As I went through the airplane, we did find some things. I think I walked away from that inspection with roughly 10 items, all of which Jim was able to correct. The biggest thing was that the elephant in the room, the scary thing in the room, was the gearbox. How are we going to manage this gearbox issue? Both gearbox failures had happened with very, very short flights. In both cases, the canary in the coal mine had been a runaway propeller. So it seemed like if we were going to have a problem, it was going to be in the first 5 minutes of the first flight, and that we should sort of build our risk protocol, our risk procedures around that. So we laid out a program that would allow us to sort of tiptoe into that as much as possible, trying to bite off that risk in small increments, building up to the owner's goal, which was to be able to go for a ride in the back of the airplane as he started his flight instruction in the airplane, sort of a lifetime goal, being interested in warbirds and Mustangs, to be able to do the Mustang thing. A lot of that risk profile, if we couldn't come up with anything that was a solid risk, was defined by the insurance minimum, which was 5 hours minimum solo for me, a pilot who hadn't flown a Titan Mustang before I could fly with a passenger. So that was a very clear minimum standard. So assuming that there wasn't a gearbox issue anymore, we could get those 5 hours, and then we could start working towards putting Jim in the back seat and building up to him doing some flying from the back seat. So a quick summary of some of the issues that were found during the inspection. First, the right aileron bell crank bolt was found to be loose. The bolt was shanked, so we just had to add a washer. Second was the right aileron trim servo was loose, some hardware that needed to be tightened. Elevator hinge bolt was not tight in the nut, so it just wasn't going into the nut long enough for threads to be poking out the far side. So again, simple fix, just a thinner washer, and now you're secure. Number 5 was the canopy lock on the crank was not functioning, so you could crank the canopy shut and then hit the stop, but there was nothing holding the canopy there. So most of these Mustang replicas have the, just like a real Mustang, they have a crank there on the right side of the cockpit, and the crank itself ends up functioning as the lock. So you would get to the spot where the canopy comes closed, dink, the canopy comes closed, and then you release the lock, and it, usually some sort of a pin. In this case, that detent wasn't functioning. There was a backup latch where the two frames came together on the canopy rails, like you would see on a suitcase or something. You could close, and that was actually what was holding the canopy shut. So we squawked that. The shoulder harnesses was just a simple loop, so it went from the lap belt up and around the top of the seat, and then back down the other shoulder, and as a result, it just sort of fell all over the place. So I just squawked that it needed to be secured. The manifold pressure gauge was sticking, so just replace it. In the briefings that I had done with the other pilots, it became clear that the flaps were an issue on the Titan Mustang with the V8 installation. It's more of a forward CG thing than a V8 installation thing. There were no indication of flap position. So with the feedback from the other pilots, it was really important not to put too much flaps in, etc. And I had no indication of flap position, so we squawked that. So people got really excited about the flap indication marks on the Hawken Lancer. So just went through that here as far as how we marked the flaps. The big thing here is that we're putting a mark on the flap itself, and that needs to be visible from the cockpit. So I'm sitting in the cockpit, and then Jim is sitting out in the wing with a protractor. Of course, we're setting a new 0 because the airplane's in 3-point. Set a 0, swing the flaps for the full extent, and then we're breaking it down for the critical marks for the flaps. Owners had said that anything more than about 50% of flaps, the airplane would run out of pitch authority in the flare. More on that later. So we want to make sure we had a mark for that. So the flaps have 30 degrees of travel. So the idea was to mark it in 10-degree increments, and then the 50% flaps would be a 10-degree mark and a 20-degree mark, and you would split it for the 50% flaps.
And first of all, do you want it so if 10 degrees is when you can see the whole black?
So the first step here was we just did full travel, full flaps down, full flaps up, and check that there is in fact 30 degrees of travel. There is. And then here you can see Jim putting down a piece of tape that corresponds to each of the 10-degree increments. A little further back. Other than that, pretty straightforward. Right about there.
Good.
Yep. Both the water temperature gauge and the PSRU oil temperature gauges were down in the footwells, so sort of where your knees would live. These two gauges got to go. I thought I could work around them, but I can't. And with my gangly legs, it wasn't working, so I asked that those be moved. One of the more interesting ones is that if you walked around the airplane, it became apparent if you just looked at the two main gear that the right main gear just wasn't pointing the same direction as the airplane. It was tweaked both in the roll axis and in the yaw axis. So I asked that the owner reach out to Titan and confirm that that was within limits, or that was acceptable. There was no reason to think that that had happened since the airplane had gotten to California, that most likely it had flown from Ohio like that. I just wanted to make sure that everybody was on the same page, that the gear was considered safe before we went on to fly it. Lastly was really directly related to the previous flights. So when Ethan was flying the airplane, in both cases, when the propeller ran away, it ran to a very, very high RPM. So I don't need to tell people that have experience with constant speed propellers this, but that is very much dictated by the fine pitch of the propeller. So if your rule of thumb is that you put just as coarse of a fine pitch in as you can bear, so that in the event of a propeller runaway, you have as much power available as possible. So long story short, if the governor fails, the prop's going to latch to the finest pitch that it can, which is set by a mechanical stop, usually up in the hub. So when it goes super fine, now you can rev the engine very, very high. It just over revs, and when it over revs, eventually it'll just push the rods through the case without ever making any thrust, without making anything that's going to hold you in the air. And when you're pawing around the field with a runaway propeller, you need every bit of thrust you can get. So long story short, you want to make that fine pitch stop as coarse as possible, so that maybe you have to redline the motor, maybe you have to go beyond redlining the motor, but you have some chance of making enough thrust to stay airborne, to paddle the airplane around the airport and get back on the ground. So I wanted to confirm that, and that was the list coming out of the ground inspection. We capped off the ground inspection with a ground run. So we pushed the airplane outside and did a run there on the ramp at the Compton Airport. This was my first time running a Titan. It was, I think, my first time running an LS motor. And it was a chance to get a feel for the interesting handling qualities, etc., of the Titan Mustang.
Checklist thing?
The other one?
Yeah,
sure.
That's the...
This is the general one?
Yeah.
Yeah, if you got the other one, I'll take it. In general, throughout this whole program, procedures were an issue. So here the two checklists that are being discussed are one, a Titan prepared checklist, and two, a checklist that Jim himself prepared. The Titan checklist, while containing all the different phases of flight, is not specific to the systems installed in this aircraft. Jim's checklist, while being very thorough and very specific for that airplane, is only just an engine start checklist, which is basically as far as he had gotten. Okay, so accessories on, avionics on, pull off the left.
Whichever, they're both full, so.
So why don't I hear it?
Oh, because the main switch. There you go.
A quick tip, trick that I like to use in these processes, especially as you get into weird engines and weird engine installations, the checklist will walk you through how to do a start. It's important that you take a second and figure out, once you engage the start, whether it's turning on the starter or engaging the start sequence or whatever it is, that you take a second and recognize, what am I going to do if I don't like the start?
Starter, just on the right side like a car. That turns the engine over, but does not turn it off. Turn it off, you have to hit one of those switches. Those are the easiest ones, yeah.
There's no mixture lever. How do I stop it? Clear. So this would be considered the low speed taxi. Basic brakes, basic tailwheel steering, all at sort of a 5 mile an hour pace. One of the big things that had come up on the phone with the other operators of the airplane, maybe you couldn't do a run up, or you would have to be careful doing a run up, that with the CG so far forward and the gears sort of far back, that at full power or maybe even at mag check or engine check RPM or propeller cycle check RPM, that the airplane would actually have enough thrust to tip over on the nose and you wouldn't be able to hold the tail down with the elevator. This could be made worse with the flaps. And now we taxi back and shut down. Obviously we're super conservative about flipping over, right? Like we've been talking about that all day. But
yeah, but it seemed to be fine, huh?
I was up to 18 inches.
Yeah.
Which is as much power as anybody's talked about running this thing on the ground.
Right, I didn't see it trying to lift it all. It looked like it was rock steady, so.
Again, I'm trying to figure out how interested in the program I am. Maybe thirsty is the wrong word, but I was very eager to have flown the third of the 3 major Mustang replica types, just for comparison's sake. But this was a moment where you're sort of trying to, piece together the reality of the situation. This is not a low-risk program, whether or not you can communicate that to the owner. So with the ground run complete, checked that box. The next step would be to go fly the airplane, assuming that the squawks were taken care of. Well, I'm sorry the clock kind of ran out on us.
Yeah.
I feel like we got a lot done though. So after about a month, it took about a month for Jim to work through the squawks, came back down to Compton for what ended up being the first flight of the airplane. Sorry, for what ended up being my first flight of the airplane. Again, there were general concerns. The previous 2 propeller runaways had happened within seconds of getting airborne. In both cases, Ethan made basically 1 lap around the airport. So it seemed likely that if we were going to have a gearbox failure, it was going to be sort of on that time scale. And then the new added thing that we'd have in our pocket is A, we were ready for it, we maybe even expected it, and B, we had changed the fine pitch stop of the propeller. We'd done a bunch of runs on the ground, so run the engine, check the gearbox, run the engine, check the gearbox, looking for debris in the gearbox after the fix. And we weren't seeing any debris. At some point you have to kind of go out and fly it. So the goal was to make just the shortest flight that we could, right? So power the airplane up, climb up right to bailout altitude. If everything looks stable, hang out for a second, but then power back, normal landing, and check the gearbox. And that's what we did.
Compton Woodley Airport, automated weather observation. 1-9-3-5 Zulu weather. Wind calm. Visibility more than 10. Sky condition clear below 12,000. Temperature 25 Celsius. Dew point -7 Celsius. Altimeter 3018.
Check. Clear prop. throttle response on this engine was incredible. A geared motor, so the propeller's not turning very fast. The propeller itself is very, very light, combined with probably a throttle friction thing. After the run-up, controls check, and then call for the runway.
Copy traffic, experimental 9-1 uniform, taking runway 7 right, high-speed taxi.
So for my first flight in the airplane, I'm trying to treat it sort of like an actual first flight. So what that means is starting with a high-speed taxi to verify the propeller operation, again, without being committed to going flying. So with that high-speed taxi complete, we just taxied back for the first actual takeoff.
Copy traffic, experimental 9-1 uniforms, clearly active.
Fist pumps for Jim.
Copy traffic, experimental 9-1 uniform. Departing runway 7 right, we'll be staying in the traffic pattern climbing up above the airport.
Standard first flight type stuff, landing configuration stalls at altitude. You can see here I'm fiddling with the flaps. They're going up and down a little bit as I try to hit that 15-degree mark. So here's the landing configuration stall. Based on this, I could see that this was going to be an issue, the CG being so far forward. With those stalls complete, ready for RTB, again trying to keep the time down to minimize the risk exposure with the gearbox. And here we are coming into landing. I think you saw it on the takeoff, but here on the landing, it's just another reminder of just how poor of an airport Compton is for flight tests, right? Yes, it's a patch of great asphalt, great crash rescue, all the things that we're gonna learn as we go forward with this program, but it's surrounded by a lot of really not nice places to land. Put the gear out. Gear is a handle on the left side of the cockpit down like below your knee. And then put the flaps out. It's mounted on the lower left side of the panel.
Traffic, experimental 9-1 uniform, left base, 25 left.
So there you can see I was having trouble arresting the descent because I was at the aft stop of the elevator. The fix there would have been to add some throttle, which would have blown the tail or at least minimized the amount that the propeller was slowing down the air that was going over the tail, or just add approach speed or reduce the amount of flaps. Again, this is my first landing. That was very good for a first landing, but we're just dialing in these systems. The other big observation is that once you're down on the mains, I liked to wheel land the airplane. The transition from tail high wheel landing to setting the tail down was very big. The airplane sits with a very nose high attitude, and you go from landing, and then I like to kind of raise the tail and plant the airplane down on the mains, gives you good firm braking. But as the elevator starts to run out of travel and you can't really hold the tail up anymore, there's that moment as you're sort of decelerating, you're losing elevator authority, you're trying to gently set the tail down. And the fact that it's so far back and you're so blind, obviously there's anxiety. Did the tail wheel come down? That kind of stuff. But also just, it's a big transition. There's a lot of angular transition, which means that all the inertia of the rotating inertia of the propeller is now translating to directional stuff, and that makes for a lot of stuff going on. If I was to comment on sort of fundamental things about the Titan, that's a big one, is that the 3-point attitude is very nose high. Got back to the hangar, and I think this guy might be my favorite part of the maybe the whole program. I hope when I get to this point in my life, I have an airport I can go to and hang out. This guy's got this 3-wheel bicycle and he seems to just sort of be cruising the airport, talking to people. He gets to be around airplanes all day, which clearly he's passionate about. He had lots to say about, you know, having spent what appeared to be a lifetime in aviation. He knew a lot about stuff that was going on in aviation, and it made him enjoyable to talk to. Reminded me a lot of myself and hopefully, like I said, a goal of where one could end up in a best case kind of situation.
It's pretty good. Right on the numbers. I watch you say you put it right on the numbers. Yes.
So that first flight was 0.6 hours from Chocks to Chocks. That put us in the air for just about 20 minutes, so about 0.3 hours airborne. With that first flight complete, we came back and checked the oil. So everything came down to the gearbox health. So we just used the dipstick to look for particulate on the oil. Of course, this oil now had 20 minutes of runtime on it. So it was it looked like very much clean oil, but there was no signs of debris. And with that, we started moving towards flight 2. In this video, you can see Jim checking the engine oil. Yes, the gearbox and the engine oil are separate. And yes, we checked both. So that brings us to flight 2. Flight 2 was basically a longer version of flight 1. Again, the goal was to take that. Now we put 0.6 on the gearbox. We wanted to bring that up to an even 2 hours before we changed the lube in the gearbox. This was going with a new plan from the owner, from Jim. He wanted to make it a company policy that the gearbox oil was changed every 2 hours until he got confidence again in the gearbox manufacturer. From my standpoint, the goal was to minimize the risk and stabilize the engine operation. So I didn't want to be sawing on the power and running weird power settings, etc. The goal was to get everything as stable as possible. So 1.4 plus 0.6 equals 2, 1.4 hours from Chocks to Chocks, orbiting at 3,500 feet, which worked out nice with the airspace there over Compton, at a cruise power setting, which we were calling 3,000 RPM and 20 inches, and then one normal landing. Again, with the things that we had learned from the first landing on flight 1, we were trying to apply that. So I went from an approach speed of 80 miles per hour, this is statute, to an approach speed of 85, and then I moved that flap setting from the 15/20 degrees of flaps that I used on the first landing to the more like 10 to 15 degrees on the second landing. Again, with those big flaps came a lot of pitching moment, which meant there was less elevator available. So by getting rid of a little bit of flap, we would have more elevator available and give us more chance to round out and stabilize that landing. Of course, this comes back to the next question, which probably everybody's already asking, which is, it sounds like the flaps aren't helping. It sounds like all the flaps are doing is actually increasing your approach speed, which is sort of the opposite reason why you would put flaps out. 1,000%. It turns out, and maybe it's obvious, but most owners, if the airplane's got a lever, they want to use the lever. So in this case, at this CG, I would argue the flaps didn't make much sense. I would say in most of the Mustang replicas that's true, because the P-51 has really big flaps, and on these little airplanes it's just that you don't need the drag. The pitching moment that comes with it is excessive, and then there's handling qualities issues. Every one of the Mustangs I've flown, the Mustang replicas I've flown, has pitch issues based on the big flaps. So why are we using the big flaps? And again, I think it just comes down to owners wanting to use them. So anyway, so the plan was to use a little bit less flap, try the flight again, put the time on the gearbox, get back on the ground, swap the gearbox oil out, and see where we were from a gearbox standpoint.
Compton Woodley Airport, automated weather observation 1935 Zulu weather. Wind calm. Visibility more than 10. Sky condition clear below 12,000. Temperature 25 Celsius. Dew point -7 Celsius. Altimeter 3018.
The flight went well, so I won't bore you with videos of me flying racetracks. However, I will show you the landing. I think there's some interesting stuff there.
Compton traffic 9-1, uniforms final, 7 right, gears down, pressure's up.
Compton traffic, Cessna 776 flight Tango turning crosswind. Compton traffic.
You can see that the touchdown was controlled, but I still wouldn't say I was happy with the landing. You can see from the over-the-shoulder angle how the elevator seemed to sort of hit that upstop, or at least I was very close to the upstop. And again, that's just a really uncomfortable position to be in when the ground's coming up, so in a flare situation. Between flights 2 and 3, we changed the oil in the gearbox, again checking for debris. I could find no substantial debris, a very, very small amount of non-ferrous, smaller than sand debris in the oil, and with that I was confident refilling the gearbox obviously and proceeding for flight 3. Flight 3 was very similar to flight 2, except that I cut it a little bit shorter. The day was getting long and I needed to get home to the family. Here's some footage of the belly of the airplane after the last flight. So we didn't clean the belly in between flights, so that's all the oil that had accumulated through 3 hours of flying in one day. You can see there's a couple drips on the ground. There's a little bit of oil on the belly, but there's nothing significant. All indications that the airplane was happy and that we would be moving towards flight 4 very soon. Flight 3 was 1.1 hours. I landed at 3:40 in the afternoon. Again, just giving me just enough time to get over the hill back to Mojave in time to give the kids bath and put them to bed. So we think that's wingtip, that's prop, and that's the left main gear. So flight 4 was scheduled to be the last or nearly the last flight without Jim in the back seat. The gearbox seemed to be performing, and therefore Jim was looking forward to starting his training in the airplane. Jim had planned on using the practice area up by Redlands Airport on the north side of the LA basin for that flight training type activity, but I had recommended the one off the south side of Torrance. They're sort of just off the coast, like you were heading to Catalina. So as a result, on this flight, I headed that direction to check out the area. It was my first time leaving the glide cone of the Compton Airport, and there was no shortage of anxiety about that.
Compton traffic, experimental 9-1 uniform, take runway 25 left. We stand in the paddock, I'm up above.
Couple quick orbits over the Compton Airport and then out to the coast. Did a couple turns and then very quickly flew back to Compton to get back in the glide cone. And then at the 1 hour mark, I was going to start doing a couple takeoffs and landings there at Compton to round out, like I said, at around 1.5 hours, getting us real close to that 5 hour minimum that the insurance had. So here we are rolling on to final. You can see that I have 3 green, so that right main is indicating down and locked.
Compton traffic, experimental 9-1 uniform, final 25 left.
Approach was normal with that 10 to 15 degree flaps and 85 mile per hour approach speed. My apologies for all the oil on the camera. This is unfortunately the best external view I have for showing the upcoming event. So that moment, I wasn't sure if I'd actually touched the wing when the gear had collapsed. I added power. I was pretty confident I hadn't touched the propeller, but I hadn't felt it in the controls that I had touched the wing. I hadn't felt a grinding on that right wing. But meanwhile, while being heroic, I'm not sure that aborting the landing had done anything else more than put me sort of in another predicament, right?
What am I gonna do now?
So after that gear collapsed, the right main indicated unlocked. You can see that on the left side of the cockpit. So I did the standard shimmy shimmy cocoa pop, directional and G oscillations to try to get the gear to shake out with no change. I also took a moment to check for handling in the roll axis. Again, concerned that right aileron had made contact with the runway. You can see here I reached for the gear like I'm gonna pull it up to commit to landing on the belly. And this was probably the first moment where I start to let the owner into the cockpit. So again, in this bigger context of Jim not being an airplane owner, there was a lot of stuff that I was sort of letting him know as he needed to know it rather than trying to do sort of a deep dive up front. And it was at this moment I knew, I had shaken the airplane, the gear wasn't going to come out. I knew now that I was going to crash today. And now my next thought was, well, how do I, warn Jim or prepare Jim for what's coming? Because, not being an airplane guy, this is all going to come at him really fast. And so that's when you can see I hesitate to fiddle with the gear, and I start figuring out, well, am I going to text him? Am I going to call him? Like, how will I let him know? Again, Jim had a habit of leaving the airport during the flights. From his perspective, again, this is a proven airplane, right? He's a car guy, hanging out at the airport maybe isn't his thing. I don't know, but he would, go away when I went away because he figured there was no reason to be there. So I needed to get him back to the airport to kind of let him know what was coming. It's at this moment that Brett came on the radio.
Hello, Compton traffic. There is what looks to be a P-51 in the left down 1425 left. Are you on frequency?
Yeah, we're on the frequency.
Okay, yeah, I'm an archer that was just parked, and I just had noticed that as I'm sure you already saw that when you went around, is that your right main kind of wheel buckled.
So this is a fascinating new variable that I've never dealt with before. I've got a fair amount of experience with, with a well-briefed safety chase. I have a fair amount of experience with indoctrinated team members that are on the ground and trying to provide assistance. But in this case, I have this voice on the radio, person I don't know personally at all, who can potentially add a lot of value. I need all the help I can get at this point, but it's hard to know what he knows, right? What is his background?
That's correct. Is there anything left on the runway?
And just as I'm starting to figure out how to talk to Brett about all this stuff, the engine tries to quit.
Everything's okay, and the gear is back down now, so you have two fully down, but it did buckle when you put pressure on it.
In that moment, you can see the dynon cycle, you can see the tax cycle. So globally, right, as an engine operator in this moment, the engine had stumbled. I knew the engine was electronically controlled, and therefore there wasn't like a mixture knob I could play with, or the fuel system was relatively simple. There wasn't much I could do, so I wasn't confident that the engine wasn't going to stumble again. And with that, I sort of realized that this whole thing was going to be over pretty quick. Another thing that sort of interestingly also gets imprinted in my mind in this moment is that I had wiggled the throttle, and that locks in as maybe being related to what's causing the engine to stumble.
When you put pressure on it.
Okay, copy all. So, you're not in any position where you could let the owner be aware of what's going on with the gear?
So at this point, I figure the engine is about to quit. I'm sort of on a base turn, sort of like I can make the runway from where I am. But again, I go back into this like bringing the owner into the cockpit thing where I'm like, God, I'd just love to warn him about what's going on. If Justin was here and he had a fire bottle, I'm wishing that Justin was here for the impending crash that's coming.
Yeah, I'm not from here actually. I'm from Santa Monica. Do you have a number you want me to give him a call and let him know?
So I give him Jim's number?
Okay, I'll give him a call and then I'll call you back with that response for you.
Thank you. And just to be clear, I'm going to want any debrief you got on the condition of that right gear.
So the customer relations side was saying, let's let the customer know what's going on. The other side was, I need to know what Brett knew, if anything, about what had happened, what things I couldn't see, things that were on the other side of the wing. What did he know about the position and condition of the gear? And based on that knowledge, helped me inform my decision whether we're going to try to land with the gear how it is, whether we're going to try cycling the gear to try to get a different answer, or whether we're going to pull the gear up and land on the belly. Recognizing I had a little bit of time here, I took the moment to clean the airplane up, so flaps up. Again, you can see I put my hand on the gear lever like I'm going to pull it up. But again, I'm waiting to try to involve Jim in the decision. Again, too much customer relations. So about 90 seconds pass here.
Okay, I just had a phone conversation with Jim, and he's going to make his way down towards the craft where we have some radio communication for you.
This next bit is some of the most fascinating like radio communication stuff I've ever experienced in flight test.
Sounds good. And then if you got any debrief on what you saw, you said the gear buckled. I'm not sure what that means.
Okay, so when your main wheels touched down, your left one was stable and your right one gave way, so it didn't really take any pressure, and it probably went inward about 20 to 30 degrees, and then you must have sensed that and did go around.
I've never met Brett. I don't know anything about his background, but the pressure is really high. So how do you maximize the efficiency of the conversation so that we can figure out who he is and get the information that he has, as efficiently as possible?
Okay, so buckled implies that the main strut may have collapsed. It appeared the strut was intact from your perspective?
Yeah, it looks so. It did. Give me a kind of a second to decipher exactly how to put that in words, but as soon as your right main touched, the entire strut itself kind of bent inwards. I guess it kind of gave way under the pressure of the lack of hydraulics, essentially.
I think it goes without saying that this is a fantastic example of the value of really good safety chase. And when we say safety chase, people think about formation, they think about being in the right position. And I think what's illustrated here is that the more important thing is that you're able to speak the same language and have confidence on both sides of the conversation, so that the things I say mean the same thing in your head and vice versa.
Right, so from my perspective, my guess is the lock failed, so the strut is intact, but the lock is no longer functioning. Does that match what you think you saw?
That is an affirmative, yes. If you wanted to do a kind of low pass here, we can kind of get an idea of what your strut looks like, make sure it looks healthy and solid still.
Again, it was more than I could communicate in the moment, but the idea of doing a low pass to check gear position after that engine stumble, it was going to take a lot of convincing to put me in that position. Not so much the coming into the low pass, but that moment after the low pass where you're depending on the engine to get away from the ground and not end up in that neighborhood of houses.
Let's give Jim a second here to get on the frequency. Temps are stable so far, but this thing doesn't like flying around with gear down.
Understandably. Do you want to try to do some, I don't know anything about this plane, some G-force maneuvers and see if you can get it to lock?
I already tried that, but no, I like where you're thinking. The only thing that's on my question mark is whether we just give up, suck the gear up, and land on the belly, or whether we had tried to put some pressure on that right gear.
Okay, give me about 2 minutes and I'll get back to you. You got plenty of fuel?
We got probably another hour's worth of gas, but I don't think this is going to last that long.
During the next 3 minutes it takes for Jim to get to the radio, I decide to climb to altitude to slow the airplane to try, again, the shimmy shimmy Cocoa Pop, but at a lower speed, and also try cycling the gear to see if I can get a different answer as far as the downlocks.
Hey, Elliot.
Hey, boss, how you doing?
So I assume you've tried the positive G thing to get the gear to lock down, right?
I have.
Again, just a fascinating communication problem.
You do have some extra gas in that rear tank. And then, yeah, how about if you try to put the gear up and down again, or that it's a side skid thing, so the airflow tries to push the gear outboard to lock it down?
We tried that already. I just haven't tried it at slow speed. So climbing up to altitude now, we'll try that.
He was saying that you're getting...
And then the engine quit. So speeds 100 miles an hour or about 3,100 feet MSL. I'm basically directly over the runway on like a high upwind near the departure end of the runway. So that's a big left-hand 180 to line up with downwind headed for low key. Low key being sort of adjacent to and opposite heading of your touchdown point. And here I have just a few seconds to try to troubleshoot. In the bigger context, I knew I was going to crash today. I didn't see that there was much I was going to do in the cockpit. Even if I got the engine running, it wasn't going to change the outcome of the day very much. But I knew that what would absolutely change the outcome of the day is not making it to the airport. So I was absolutely focused on making it to the airport, less so on troubleshooting. Again, based on that previous stumble, I believe that sawing on the throttle had something to do with the engine quitting. Obviously it didn't work this time. And then it's a basic check of the switch positions in the cockpit. So there's three main switches that control the engine. There's the starter switch, the coil switch, and the fuel injector switch. And then there's the row of circuit breakers. I check all those. And then after that, just few seconds of troubleshooting, it's just focused on trying to make the airport. So this is an interesting moment where I decided I was high. So I make a couple S-turns, the last one of which is pretty deep. And then I turn back to the north, back towards base, and that's when I knew I was in trouble. That last S-turn was just way too deep, and now with the wind coming out of the north, I was gonna have trouble making the airport. So I reached down and feathered the prop to increase my glide ratio. So again, there's different schools on whether or not you feather the prop or when you feather the prop. From my perspective, if I have the airport made, I'd rather keep the prop in the fine position so that I have it in moments like this as a last get out of jail free card to make the airport. I'm sure there'll be people that, that feel the other way about it, that you should feather immediately after an engine failure. So you can see right here as I'm cutting that corner from base to final, I think I can make the airport, but I know it's gonna be tight.
Okay, so we've got a P-51 replica coming in with a gear issue. We've been communicating with him for the last 15 minutes.
It's hard to communicate on a long emergency like this just how tired you are at the end of it. And I didn't really feel it until this moment when the airplane came to a stop and I had to chant to myself, fire, 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 to remind myself what was the rush to get out of the seat. I was just exhausted.
I can't hear you. I got earplugs.
I was the British guy you were speaking to on the radio.
I appreciate the help, man. No, the engine quit right as we were talking.
Oh, wow. Congratulations, man.
We're here. I appreciate it. You were very helpful.
Thank you. You're very welcome, sir.
I know you had other things to do today besides deal with
Absolutely
this.
not. You guys all right?
I'm assuming you're pilot in command.
That's right. That's me.
So the big question, what happened?
Lee, you gotta move the truck out of here. You don't got no beacon on your truck.
Specifically two things. Number one, why did the gear collapse? And number two, why did the engine quit? First question, why did the gear collapse? The short answer is we don't know. Talking to John Williams at Titan Aircraft, there has never been a gear collapse when the gear was down and locked. So that would lead you to believe that the gear was rigged improperly, and that's what caused the gear to collapse.
Emergency started with it was an attempted landing.
Just so we're clear here, I'm not here to assess blame. The NTSB has finished their investigation, the FAA finished their investigation, the insurance company has finished their investigation. I'm not here to assess blame, I'm not here to talk about who made mistakes.
They're airborne for probably another 15 minutes, during which time we scrambled Jim. That's Jim right there.
So there's two people that touched the gear recently. First was John Williams during the engine installation at Titan. At the very least, that whatever he did to the gear would have had all the landings it took to get the airplane from Ohio to California, which we'll say is 10 landings, plus Ethan's 2 landings, and then my, say, 5 landings. So that's what, 20 landings since John touched it.
Got Jim on the radio just in time for the complete electrical failure.
The other person that had touched the gear is the owner, Jim. Jim touched it in between Ethan flying the airplane and my flying the airplane. So, you know, whatever my 5, 10 landings, something like that, had all happened since Jim had touched the airplane. So regardless of whether the problem came from the work that was done in Compton or the work that was done in Ohio, there were several landings after that work was done where the gear functioned properly.
I was a little bit short, a little low on energy.
The next question is, why did the engine quit? So the short answer is that the hydraulic system took out the main bus, and the main bus took out the engine. Again, we've already talked about the airplane is non-redundant, so it's all automotive, non-redundant, electrically driven fuel injection and ignition systems. So without a main bus, you don't have an engine. The last piece is the relationship between the mechanical downlocks and the hydraulic system.
Pulled the prop back and was able to extend the glide. So you can see where we're at right now. The displaced threshold is just past that taxiway there.
In most aircraft that use the Parker hydraulic power pack, which is most home builds with retractable gear, they use the pressure switches that are installed in the power pack. So there's a high pressure switch and a low power pressure switch. When the pressure in the system gets below a set point, the pump turns on, and then when it reaches the high set point, it turns off. So therefore, from my perspective as a pilot, when I saw that the gear had collapsed and I looked down and checked that we were at 450 PSI, which is the high pressure set point for the system, my assumption was that the pump had cycled off, but that it was holding pressure. If the pressure had not built up, one would assume that the pump was on. Since it was at the high pressure switch limit, one would assume the pressure switch was off.
And was able to hold the right main up for a little while, but it wouldn't take any pressure, so it pretty quickly collapsed. Once it collapsed, the wing dug in and spun around, went for a little bit of a ride.
The difference is that Titan turns the pump on and off, not with the pressure switches, but with the downlocks. So as soon as that gear collapsed and the light in the cockpit turned off, the pump turned on. And since the transition light, which is called out by the Titan plans, was not installed, there was no way for the pilot to know that the pump was running.
Airplane never flipped over, obviously.
So what happened was the pump overwhelmed the main bus. The main bus has a circuit breaker. The circuit breaker is not in the normal line of circuit breakers on that bottom row. It's above the master switch up on the top of the panel. And then that circuit breaker was set to the plans to be at 25 amp breaker. It was a 30 amp breaker, which is good that they sized that breaker up when they installed the big fuel pumps and the hydraulic pump in the airplane. However, the fuel pumps plus the hydraulic pump meant that every time the hydraulic pump was turned on, that load combined with the fuel pump load of the airplane was above that of the main breaker, the 30 amp breaker on the main bus. Which means that every time that airplane took off and the gear was cycled up, the engine could have quit the way it did on that flight. It hadn't, and it's again back to that bathtub concept of risk. While we had assumed that since we got through that first 140 hours, we had exposed the airplane to most of these scenarios, this was a scenario that the airplane had not been exposed to. So here's a rough timeline of the events, things of note. From the aircraft coming to a stop to the first emergency vehicle arriving on scene, which was the airport vehicles from the Compton airport, was just about 50 seconds. You can see the firefighters foaming the airplane. That's Compton fire rescue procedure. Anytime gasoline is found at the scene of the accident. So basically, it's not surprising, but the fuel sumps break off when the airplane's sliding on the ground, and then the fuel tank's basically empty into the grass. Once the fire department sees the gas, they want to foam the airplane down. Back to some other points. It was really cool to see the fire department so eager to help, so eager to maybe exercise their toys, however you want to put it, but they were clearly excited to be there, excited to support, despite it being a very hot day, and wearing fire uniforms in that weather I'm sure wasn't fun. As a kid, you know, you get in trouble, and the thing that always bothered me the most about being in trouble is when I realized how much I was inconveniencing other people with my silly decisions. There was definitely a moment like that here. They actually shut the Compton airport down for the entire time that we were on the runway. During that time, the airport was closed, and a Moonie came in and landed. Obviously hadn't checked the NOTAMs. They tried talking to him on the radio. He was having a radio problem, so he couldn't hear them telling him that the airport was closed. Watching this guy who was clearly, you know, just out for an easy Saturday flight or whatever, get ramp checked effectively because he popped a NOTAM, because you know, I crashed an airplane on a runway, was a hard moment and an interesting byproduct of the events of that day. Here's some interesting views of the airplane after the wreck. You can see, yes, the right wing made contact after the gear collapsed on the final time. It's hard to know whether it made contact the first time. My guess is it didn't, but we have no way of knowing. But you can see the damage to that outboard rib of the aileron. Here's the wrecker when it first showed up. Interesting side note, wreckers actually charge not only for the number of hours they're on site, but for the number of times they change the load, they pick it up. So it turned out we had 2 pickups. The first pickup was just to get the propeller off, pick the airplane up enough that you can pop the propeller off, and then we could get a better grip on it so that we could lift it and drag it back to the hangar. Here's the wrecking company that did the work. They did a really good job. If you told me that you were going to hire a semi-truck style wrecking truck to come pick up the airplane, I would have been really nervous. Yes, it was clearly a challenge for them to pick up something that was so light and fragile, but I was impressed with the good job that they did. So the plan was to put the bulk of the load on the engine mount and then allow the tail to drag on the ground. The plan had been to stabilize the wings by hand, just 2 guys walking next to the airplane. The wrecking truck has those cables that are independently controlled, so he could actually just put those as just sort of guide wires, put just a little bit of tension on them and stabilize the airplane and roll. And then, you know, like I said, the bulk of the weight was hanging off the engine mount with a little bit on the tail, and drag it back to the hangar. And then, like I said, here we are 5 hours later after crashing the airplane, pushing the airplane back into the hangar. Thank you for staying with us for the whole video. I know it was long. I hope you got some value out of it. If you have any questions, things that didn't make sense, I'll meet you in the comments down below. There's a lot here. It's a complex thing. It was hard figuring out how to edit it, what to leave in, what to leave out. There's plenty of stuff that got left out. So let me know in the comments, and we'll try to give you the feedback that you need. Thanks again for coming along. Airplanes are cool.